You know that old saying, seeing is believing? For, well, basically all of human history, what we saw with our own eyes was the ultimate proof. But what if that foundation is just crumbling? Today, we're diving into the world of deepfakes, a technology that's not just about fake videos, but one that's kicking off a brand new arms race for the very idea of truth.
So let me just ask you that straight up. Is seeing still believing? Because in the age of AI, the answer is getting incredibly complicated. I mean, if any video, any image can be faked perfectly, what is not due to evidence, to journalism, to our own memories?
And this really is the heart of the matter. This isn't just about touching up a photo anymore. We've gone way past that. We are talking about a massive paradigm shift. We're moving from just altering media to literally synthesizing entirely new realities from scratch, creating events that never ever happened. To really get how big of a deal this is, we kind of have to look at how we got here. I mean, faking photos isn't new, right? People have been airbrushing things and people out of pictures for a century. But what we're dealing with now, it's a whole different beast. Okay, so look at the difference here. The old way was manual, painstaking work. You needed a real artist with serious skills to pull it off. But deepfakes, that's all automated. It's driven by algorithms that don't just tweak what's there, they generate something completely new. And the scariest part? The tools are becoming available to pretty much anyone.
So, how does this magic trick actually work? How can a machine create a video of someone saying words they never spoke? Well, the secret sauce is this really clever, kind of competitive system. At the core of a lot of these deepfakes are things called Generative Adversarial Networks, or GANs for short. And honestly, the best way to think about it is like a duel between two AIs. You've got one AI that's the forger, the generator, and its whole job is to create the best fake it can. And then you have the other AI, the detective, the discriminator, whose only job is to spot that fake. And this is a constant game of one-upmanship. The forger makes a fake. The detective says, nope, that's fake, and here's why. The forger takes that feedback, gets better, and tries again. But at the same time, the detective is also getting smarter. This relentless competition just forces the fakes to get better and better and better, until they're so realistic they can fool not just another AI, but you and me. All right, so if the forgeries are getting that good, how in the world do we fight back? Well, that takes us to the other side of this arms race, the world of deep fake detection. Think of it like a digital CSI unit, hunting for these tiny, ghostly clues the forger accidentally left behind. In the early days, you could actually spot the giveaways if you knew what to look for. The first deepfakes famously didn't blink because they were trained on still photos where people's eyes are open. You could also spot things like weird shadows that didn't make sense, or blurry seams around a person's face, or skin that just looked a little too smooth, a little too plastic. But, of course, the forgers caught on. They fixed the blinking, they smoothed the edges. So the detectives had to get smarter. They realized the most reliable clues weren't the ones you could see, but the ones buried deep inside the data itself, the digital ghosts in the machine. And this is where it gets really fascinating, almost like something out of science fiction. Researchers started using a medical technique called remote photoplethysmography, or RPPG. It's a technology that can literally detect a person's pulse just from a video. It works by measuring these microscopic changes in skin color that happen every single time your heart pumps blood. It's a signal that's completely invisible to our eyes, but an algorithm can see it plain as day. And here's the brilliant insight. A real human in a video has a heartbeat. An AI-generated face doesn't. The AI is so focused on making the pixels look right that it doesn't bother simulating the underlying biology. So by searching for this ghost heartbeat, detectors found this amazing biological giveaway that a video was a fake. And it's not just biology. Detectives can also look at an image's frequency data. You can think of it like a digital X-ray. The process of generating an image with AI leaves behind these unique, invisible patterns, basically an AI fingerprint that forensic tools can pick up on, even if the image looks absolutely perfect to us. But here's the catch, and it's a big one. For every brilliant new detection method someone comes up with, there's a team of developers on the other side working to make their fakes immune to it. This isn't a battle that gets won. It's a perpetual, never-ending arms race. And you can just watch this cat and mouse game play out in real time. Back in 2018, detectors find the no-blink flaw. By 2019, deepfakes are blinking perfectly. In 2021, we figure out how to use RPPG to find the missing heartbeat. And now, advanced fakes are already learning how to mimic those biological signals.
Every single breakthrough for the detectives just becomes the next homework assignment for the forgers. And this leads to this really dangerous social problem, sometimes called the liar's dividend. When everybody knows that perfect fakes exist, it becomes super easy for a bad actor to dismiss real evidence as fake. It completely weaponizes doubt and just erodes our shared sense of what's real and what isn't. So if chasing fakes is a losing game, then what's the alternative? Well, the industry is starting to pivot to a whole new strategy. It's a strategy that isn't about detecting fakes after the fact, but about proving what's real from the very start. This is a really fundamental shift in thinking. Instead of reactively asking, hey, is this thing fake? This new idea of proactive provenance asks, can I prove that this thing is real? So the goal moves away from finding flaws and towards creating this secure, verifiable chain of trust from the second a photo or video is even created. One of the leading examples of this is a new standard called a C2PA. And the best way to think about it is like a digital nutrition label for your photos and videos. So a camera with this tech built in basically signs the file the moment it's captured. Then, every single edit made to it is securely logged. So later, anyone can look under the hood and see exactly where that file came from and everything that's happened to it since. But you guessed it, even this isn't a silver bullet. There's a big vulnerability people call the recapture attack, or the analog hole. I mean, what if you just play a perfect deepfake on a high-res monitor and then film that screen with your brand new trusted C2PA camera? Well, the new file will have a perfect, valid signature, but the content inside it is still 100% fake. And what this really shows us is that there's no single magic answer here. The future of defending the truth is going to have to be a hybrid one. It's going to mean combining these proactive systems that prove authenticity with the reactive systems that are always hunting for fakes. You need both to create a real layered defense. Which leaves us with a final and honestly pretty massive question. As this technology just keeps getting better and better, we have to imagine a future where fakes become truly perfectly indistinguishable from reality. And in that world, will truth not be about what we see with our own eyes anymore, but just a matter of who has the right digital signature? It's a huge question about the future of information itself.